Alright guys, we're in my little 3D printer setup. So right now I'm 3D printing some Headway cell holders, and I'm going to show you guys what we're going to be using these for. Alright, so we're back in the kitchen. So this is kind of the final product off the 3D printer. It needs a little bit more tweaking as far as the tuning on the machine to get the upper parts perfect, but this works just fine. So we're going to take this little holder, we can take our little cells, or headways. Okay, the greens fit. That machine print's kind of tight. I'm not going to force them. I don't want to mess the plastic up. But basically, I reamed these out to get them to fit. So I did this. I printed a bunch of these, and this is the result. I'll show you guys. So this is going to be a 16S 48 volt electric bicycle battery. It's a one-piece 16S, so it's going to be an 8 amp hours at 48 volts. I'm building this just because I want to be able to test some of these cells since I have a bunch of them. And then for the BMS, we're going to slap this on there. This is a 150 amp Daly BMS. It's got a Bluetooth dongle so we can monitor voltage. Here's the balance here's the balance harness, and we're going to use bus bars. So in this video I want to put this entire pack together, and then we're going to slap it on an electric bike probably in a later video, and we're going to go range test, and I want to see how far we can get with just 8 amp hours worth of Headway cells. So this is 16, so I've kind of already skipped over throwing them in. I just didn't think it'd make a good video until I was like, wow, these look pretty cool. So I just wanted to kind of show you guys. The reason why they're different colors is because I'm using 3 different printers, and that's just the filament they were loaded with. So pretty freaking nice. I'm probably just going to mount the BMS on the side like that and just kind of take this all up together to make a nice unit, and then we can stick this on a bike and kind of see how good it works. Alright, so first step is identify which one of these is going to be your main positive and which one's going to be your main negative. So what I'm going to do, I obviously already got them in, so we'll use this as our main positive. So now we're going to go positive to negative on this side, put a bus bar. That's it. You're just going to go all the way up and down, one at a time. Careful doing this so you don't arc it. So positive, negative, positive, negative. So come back up. Hands on, so let me get the battery done. I'll speed this up for you guys. It's not boring. See big sparks. You can handle it fast. So yeah, basically we're going to go like this, so we're going to start working them up. Alright, so our first string done, we get this string, and we got to connect over this side. So 2 bus bars. Then no, going straight this way. Okay, so last connection here, that goes up here. So you go positive, negative, so on, so forth. And the fan here in the background of the inverter. We're running the AC unit today. It's nice and sunny, getting some of that free solar. This obviously will be charged with solar. Positive, negative, positive, negative, positive, negative. And you go range test to see how much we can actually get out of an 8 amp hour battery. You'll notice this is quite large for an 8 amp hour battery. Lithium iron phosphate is not the most energy dense chemistry you can go with. It is safe and it has a long cycle life, but it's a little bigger than, say, a lithium ion pack. You go lithium ion battery, it's probably the same capacity and take up a little less space, so just something to keep in mind. But I really like using the lithium ion phosphate chemistry. That's why I use all battery builds. Oh wait, I messed up. Negative, positive. Ooh, hang on. I did something wrong. Positive. Alright, so basically I have built in a 2 8S packs. So it basically snakes like this. So this is one pack, this is another. Now all we got to do is series these, and we should have 48 volts there if I did this right. And then this is turned all the way down, so don't worry too much about using power tools. I assure you it's as low as I can get it. Okay, 53. Ooh, I can actually feel that. I think I was touching it. 53. Alright, so now that all the terminals are actually tightened, 53 volts. So now I'm going to go ahead and get all these eyelets put on the balance connector. So that's pretty boring, so I'll go ahead and get all this done off camera. Okay, balance harness is all done. This is the connector we're going to put on. It's an anti-spark XT90. and our BMS. So I guess I'll start by putting the battery minus on the battery minus and then securing it to the side somehow. So without stretching the heck out of the wire. And then also, while you're doing that, get your negative balance cable connector. So this is the most negative on your balance harness. It's all live, so when you start doing this part, be careful, don't arc it out with the rings or stuff like that. Boom, so that's it. So now I'm gonna go one by one with our thing, and you gotta go to the next positive cell, to the next, so on and so forth, and then all the way until you get to your last positive, which is this one, as you can see, and it's gonna go right there. So this is the most important step. This is the easiest step to mess up, so take your time putting your balance harness on your battery. If you're unsure how to do it, all these BMSs come with the instructions on how to do it, but basically you just put this on the next cell positive. So this is negative, we're gonna go to the cell positive and just kind of go back and forth, so on and so forth. This positive on that one. And so on and so forth. So let's go here. Alright, now, I'll show you guys what it looks like. So you see this side, all hooked up, and then what we're going to do is kind of take the balance wires and I'll zip time up and make it look all neat. And do the other side. And then the last balance wire is going to go on your positive terminal right here. So I'm going to go ahead and make the positive terminal hook up to that, and then our minus is on BMS, and then we're done. So I'm going to get the small tip so I can kind of clean all this up. Let's mark it. That's right here for now. Okay, so much better. Flip it over to the same to the other side. Oop, oh no, what's my camera? I just clamped the drawer on my machine. Okay, much cleaner. And we'll organize this fast once the BMS is on, so I guess I'll get a big zip tie and wrap that up now. I'm gonna go around the bus underneath because I'm not putting pressure on it. I guess I can have it too. Make sure we're underneath. Same on this side, or go underneath. Actually, right here looks like we'll match up pretty nicely. Okay, not janky, but just temporary. This is really just for testing purposes. I'll put one more just for safety. I really like these cell holders I found on, I think they first had the file for the 3D printed cell holders, so. Okay, so now I'm gonna put a terminal right here to go from this to the XC90, and we'll do the same to the other side. So I'll do that real quick. Got our discharge lead connected. It's kind of thin wire. This is just for testing. This isn't a permanent setup, as always. I need to wrap this in electrical tape, but we have a nice connector to hook up to the electric bike controller. Now to test to see if the battery works, I went ahead and connected the Bluetooth module. When I buy these, I try to buy the smart ones because I see how useful they are. So we're gonna go ahead and connect this. I think it's connected. Nothing smoking yet. Okay, now we're gonna go here. Gonna connect to it. There it is. I have two other Bluetooth BMSs. Okay, and we're live. So it looks like all this. It's gonna be hard to see because the GoPro doesn't focus very well. Yeah, it won't focus. Anyways, so we have a total of 53 volts. So that's pretty good. We're gonna put this on a charger, top it up, and then we're gonna stick it on a bicycle and go right around. Try to get some data and see how the punch is. Hopefully it'll be real torquey because how many amps these Headway cells can push out. But that's it. I'm gonna kind of wire tie this a little bit better. All you got to do is put this in a box and you're done. This is a complete ready to go battery that can do 200 amps of discharge. So that's amazing. So next we got to do range test. So we're gonna go stick this on a random bike I have, and we're gonna fully charge it, fully discharge it, and kind of see what kind of range we actually get out of 8 amp hours. All right, guys, here's our test mule. So 1,000 watt ebike kit, tops out at about 30 amps. So all we gotta do now is charge it, put my little adapter to run the XT60 I already had on here, the XT90. That's it, we're gonna go ride this thing. It's got a little speedometer and what's it called, a trip meter on it, so we should be able to see how far we can go. So I'm gonna go ahead and put this on the charger. It's a 5 amp charger, so it'll take at most 2 hours. All right guys, so literally right as I was about to go ride the bike to test everything out, I go to hit the throttle, the bike instantly loses power. So I go into the BMS settings, and one cell was reporting 1 volt. Now mind you, I just fully charged this. So I'm like, all right, I start prodding around, maybe thinking my balance wires are messed up or something. So I start taking the battery apart. Now this is why you want to be careful. I had one of my bus bars short out for just a second and it exploded and shot molten metal everywhere. So be really careful. Nothing was damaged. It kind of just burned the battery a little bit, but I think the battery's fine. I don't think it hurt nothing. But I got the cell out, the suspected cell, and I want to show you guys what I found. But yeah, just be really careful when you're working on your battery. So this is the cell I pulled out, and the first thing I noticed, nothing abnormal, but when I go to check the voltage, point something, but then look, you move the cell around a little bit, then it gets 3. Now it's nothing. Or now it's like 2.9. So something's going on inside the cell. And then I noticed something too when I shake it. I don't know how well you can hear that, but there's something like, it feels like something inside the cell is moving around as you do this, and it feels like it's going back and forth. So I was like, all right, maybe that's just how they are. So I grabbed another cell, did the same test, no shaking at all. So I think what happened is either this cell leaked all the electrolyte out or something happened to this thing, but it is toast. So unfortunately, I have a bad cell out of my grouping of, I bought 96 cells. This one's bad, so I'm just gonna discharge it slowly and just destroy it, or obviously recycle it correctly. But anyways, I just thought that was interesting. Of course with mine, look, I had a bad cell, so I'm gonna switch it out, put this cell in there, I'll put this all back together, reattach it to the bike, and hopefully now see if it actually works. But I'm gonna have to top charge this alone because this battery was pretty much full. But anyways, I also wanted to show you all this because like I had the battery on its side, and when I took the bus bar off, it slid over and shorted. So just be really careful when you're messing with this stuff. That's a lot of amperage. I mean, if these can really push 200 amps, I mean, it made mincemeat of that bus bar. But anyways, I'm gonna get rid of this bad cell, put in another cell, and we're gonna finally go ride our electric bike. But I just wanted to show you guys that. I was literally ready, did a little test into the throttle, and then it died, and I spent about 30 minutes troubleshooting just to find it's a bad cell. So I'm gonna get this new one slapped in there, and then we'll kind of go from there.